Hello everyone and welcome to Chapter 9, Hypothesis Testing. Here's our situation. You're the owner of a local bakery and your best-selling product is a pound cake. This pound cake is supposed to weigh 1 pound and have a standard deviation of 0.13 pounds. After you hire several new employees, you notice your profits start going down. You believe the cakes are being produced heavier than 1 pound. So one day what you do is you pick 30 random cakes and you weigh them. The mean weight of those 30 cakes is 1.05 pounds. What you want to test here is you're trying to see if 1.05 is really a big difference compared to 1. So does this sample give us evidence to fire our new personnel? We're going to use our statistical knowledge, and what we're going to do is first we're going to base it on things we already know, which is a confidence interval. We're going to use our 4-step plan and we're going to create a confidence interval. We know that people's jobs are on the line, so we want to be pretty sure that this sample is just not happening by random chance. So we're going to be using the 90% confidence level. We're going to use our 4-step plan. Here it is. State what it is you want to know. We want to estimate the true mean weight of pound cakes made in our bakery. We're going to plan by constructing a 1-sample Z interval. The reason it's Z is because sigma is given to us, the population standard deviation, 0.13 pounds. It's a simple random sample. We're going to assume that we make more than 300 cakes in a day, and since n is greater than or equal to 30, we're okay using normal calculations. So let's go over to our calculator and construct our interval. In case you forgot how to do that, you go into test, stat, test. We're going to go down to Z interval, number 7. We're going to do this from statistics. Plug in 0.13. Our X bar was 1.05. Our N was 30. Confidence level's 0.9. Hit calculate, and there it is. Here's our interval. So what does this mean? So we have to finish the do, calculator Z interval. I plugged in my numbers. There's my interval. Conclude. We are 90% confident that the interval from 1.0035 to 1.0965 contains the true mean weight of pound cakes produced at our bakery. Since 1's not contained in our interval, there's good reason to believe that the cakes are being made heavier. So we're going to fire everybody. Don't get confused with just because this is a random sample and the next one may or may not contain it. What we're basing it on is our interval that we found. Based on this interval, we're 90% confident that the true mean weight is not in here. So we're saying get rid of everybody. Well, since we know the actual mean, mu equals 1, there's another way of doing this. And we are going to compare it to an X bar of 1.05. So instead of doing a confidence interval, we're going to do something called a significance test. In a significance test, you start by making some careful claims, things we're going to compare. In our problem, we believe the true mean weight to be 1 pound. We're seeking evidence against this claim. So what we do is we call this our null hypothesis, null meaning that nothing's being changed. If the true mean weight is 1, well then we believe that nothing is being changed. That's what is happening. That's what's going on. We're going to have an alternative hypothesis, and in this case, we're suspecting it to be higher. And you notice here on the screen, HO, H naught is when you use for your null hypothesis. HA is your alternative. In our case, we feel it's going to be greater than 1. And down the bottom, they give you a quick little definition of null hypothesis and alternative hypothesis. So again, you stick with the 4-step process. In testing, it's done the same way as if you were doing a confidence interval. But the big difference is the step 1 when you state what's going on. What you do is you state it in symbols and words, and you have to identify what your variables represent. What we're saying is our null hypothesis, what we believe is that mu is equal to 1. But our alternative, and this is what we feel we have evidence to show, is that mu is greater than 1. And down the bottom underneath, you would write it exactly like this, where mu is the actual mean weight of pound cakes being made in the bakery. And what we're going to do is we're going to test at a 0.05 level. And that means we're going to use alpha to represent 0.05. Alpha is called your significance level. You state it ahead of time at what level you're going to test it. Because this way, we're either going to reject or fail to reject our null hypothesis based on that level. You always set your level ahead of time. It's kind of like where we set our confidence interval. We're going to be 95% confident, 90% confident. Here, it's kind of the other way around. You're saying we're going to test at a 0.05 level. Very similar to how we were doing a 95% confidence interval. Step 2, we check all our conditions the exact same way we did when we created the confidence interval. Nothing changes in those situations. All right, third part is the doing. All right, instead of going in and doing a test, an interval, we are going to do a test. So let's go over to our calculator. And really, you shouldn't have written anything down for the interval. This is the time that I really want you to write stuff down, is for the testing, because we've done intervals before. So step 1, that's different where it says state. It's different than what we wrote down when we were writing down the confidence intervals. I want you to write down what I had written down there in step 1. Step 2 is exactly like what we had in the confidence interval. But let's go into stat and go over to test, and you'll notice there's a z-test, a t-test, and a 1-prop z-test. Well, we're going to do a z-test. Why are we doing a z-test? Why? Because we know what? We know the population standard deviation, and we're going to do this from statistics. Now, what we're going to say here is that our mu is equal to 1. Our sigma is 0.13. We got an x bar of 1.05. That was our sample. There were 30 of them. We believe that it's going to be greater than 1. You can do not equal to, you can do less than, but what we're trying to test is we thought that bread was being made, or the cakes were being made heavier, so we're going to do greater than 1. So we're going to calculate this. And we're going to get a few different things here. This says for mu is greater than 1, you get a z-score of 2.106. So what does that mean? That means how far away from the mean is this? 2 standard deviations away. And we always said anything more than 2 standard deviations away, we consider that pretty significant. This p-value tells you whether something is going to be significant or not. We are testing at the 5% level. So anything less than 5, any p-value less than 5, we're going to consider significant. When something's significant, and this is the most important part of this whole lesson here, when it's significant, we reject the null in favor of the alternative. So we're going to state all these things that I'm saying right now when we go back to the PowerPoint. What's real important to know, here I was doing greater than 1 because I had reason to believe that it was heavier. Sometimes just say I believe that the cakes are going to be different than 1, so then I would do not equal to. We'll talk about that another time. Let's go back over. All right, I did my z-test, and here's exactly what I plugged in. I had my null hypothesis of 1, standard deviation, x bar. And then what we did is we found our test statistic, which is our z-score, 2.106. 0.1066. Gave us a p-value of 0.0175. Small p-values are statistically significant. Anything smaller than our set alpha means that we reject the null in favor of the alternative. And that's exactly what happened in this situation. So our final thing, our conclusion down here is because the p-value, and you state it exactly like this, because the p-value 0.0175 is smaller than our alpha, our significant level, we reject the null. We have convincing evidence that the mean weight of pound cakes is actually greater than 1. And again, we go back to firing everybody. All right, so that was pretty good. We're going to end with a little music. I was supposed to have background music while I was doing this. All right, we're going to practice some more problems in the book. Thanks for listening. Hopefully this helps you understand significant testing.